Yeah, now we can see the properties of transaction. So very important. So here database transaction properties, simply we can say acid properties. What is A? A for atomicity. Okay. C for consistency. I for isolation. Okay. D for durability. Okay. So what is meant by atomicity? These are the, so we will discuss slowly atomicity. So what are the transaction properties? Transaction properties that a transaction should possess in order to avoid failures during concurrent access to a database. Okay. So this point is very important. What is the need of transaction properties? These are the properties that a transaction should possess in order to avoid failures during concurrent access to a database. So all of you remember, so normally if I am asking a student what are the properties of a transaction acid, so what is the use of these properties? Okay, so these are the properties that transaction should possess in order to avoid failures during concurrent access to a database. So here ACID is a acronym which stands for atomicity, consistency, isolation and durability. Okay, now here, so what is atomicity? Atomicity is nothing but, what is atomicity? Atomicity is ensures that transaction should either be executed completely or not at all. This is because incomplete execution of the transaction results negative consequences. Okay. So here atomicity means execute all the instructions completely. So see here, either transaction will be done. Done is nothing but executed completely or not at all. Why? Because if there is incomplete execution of the transaction, that results negative consequences. Okay. So that means we are considering always transaction is a single unit of processing. Okay. So in this processing, we can say that all these statements are executed successfully or not at all executed. Okay. So this is called atomicity. And next, see consistency. Already I explained you database is consistent in the beginning of the transaction and consistent state at end of the transaction, but there is a change. Okay, when it executes completely the transaction, so it changes from one consistent state to another consistent state. Okay, all of you try to understand. Okay, it changes, the database execution takes place continuously. So database from one consistent state to another consistent state. Okay, if a transaction fails even, okay, so this also we discussed the rollback condition. It fails even, the database should come back to a consistent state. That means it will come to the database at beginning of the transaction consistent state. Okay, so that is called consistency. Next, what is isolation? Isolation is nothing but all the transactions must run in isolation from one another. That means all the transactions executed successfully, that updates of the transaction should not be visible till they are committed. Okay. So this point you have to remember, should not be visible till they are committed. Whatever the updates happened in the execution process, that updates will be not visible. Okay, so when these all are updates are visible, so when it is committed, okay, this isolation guarantees the progress of other transactions do not affect the outcome of the transaction. Okay, so every transaction should be kept unaware of other transactions and execute independently. Okay, so that you have to remember. See, I given an example. Slowly we will discuss acid properties with an example. So, but today you try to understand what is atomicity, consistency, or isolation, or independence, or durability. What is meant by durability? This property ensures that the data remains in a consistent state even after the failure. Okay, this property ensures that the data remains in a consistent state even after the failure. This is ensured by loading or modified data into the disk. This task is handled by the recovery management component of a database management system. Okay, this is called durability. So see, try to understand. After successful completion of a transaction, the changes in the database should persist. Okay, changes in the database must saved into the data disk. Even in the case of system failures, whatever the changes at the beginning of the transaction, that values must be saved into the disk. Okay, so this point you have to remember. This is called durability. So acid acronym stands for atomicity, consistency, isolation, and durability. So once again, I am explaining for you. So what is atomicity and what is consistency, isolation, or independence, or durability? Atomicity is nothing but it defines or it ensures that the transaction should either be executed completely or not at all. This is because the incomplete execution of the transaction results in negative consequences. This is called atomicity. Consistency, the database in the database must always be in consistent state. Okay, when it completes successfully the transaction execution, the database from one consistent state to another consistent state. It changes from one consistent state to another consistent state. So this is called consistency. Okay. So isolation, whatever the updates happen in the execution transaction process, executing the transaction process or executing the unit of process. Okay. So these updates, okay, should not be visible till they are committed. So this is called isolation. Every transaction should be kept unaware of other transactions and execute independently. So that's why this is called isolation or independence. Okay, next, last one, durability. What is a durability? This property ensures that data remains in a consistent state even after the failure. Even after the failure, the database must be remains consistent even if it executes successfully. So it saves committed the changes. Okay, if in failure, okay, so the database is in consistent, the outcome of the transaction even if failure also the database is in consistent state. That means in failure, so what will happen? Roll back, resets, any changes. Okay, the outcome is only database in consistent state. So this is called acid properties.